For tonight's homework, we're going to continue to explore proportional relationships, how we graph them, how we write unit tables, and how we represent them with equations. So make sure you've tried the problems on page 11 and now use the Zaption to correct your work. Joel can drive his car 450 miles at a steady speed using 15 gallons of gasoline. Let's start by completing the rate table. So you know this value here, 15 gallons with 450 miles. And they also gave us this one in the table, 5 gallons with 150 miles. So I want to probably think about how many miles can I drive per gallon so it can help me build up my rate table. So I might use either one of these that I already know. This time, let's say I just use this. 5 gallons for 150 miles means 1 gallon is how many miles? Well, 5 times 1/5 would be 1. 150 times 1/5 would be 30. So it's 30 miles for every 1 gallon of gas. So as my gallons goes up by 1, miles is going to go up by 30. So 30, 60, 90, 120, 150, 180, 210, 240, 270, 300. So there's my rate table. Now I want to think about the 2 unit rates. So I've already found one of the unit rates. I found 30 miles per gallon. That means 30 miles per 1 gallon. So that's one of the unit rates. It's right here in my table. The other unit rate's a little trickier to find. This one I want to know how many gallons per mile, per 1 mile. One strategy would be to set up a proportion. So again, if I take my 5 gallons and 150 miles equals how many gallons for 1 mile. And again, I could have started with any number of different proportions over here or different ratios here. I could have done 1 to 30. I could have done 15 to 450. I just chose 1. So this is going to be a scale factor of 1/150th. And when I multiply 5 times 1/150th, or 5 divided by 150, I get a lovely decimal here that's about 3/100ths. And that 3 actually repeats, so I'm going to draw a little line over it. So this is a really small number. It's about 3 1/3 hundredths of a gallon per mile. And so this is my other unit rate. So now I'm going to use those unit rates to build up graphs. So thinking about my 2 unit rates, I had 30 miles per gallon, and I had 3/100ths, and that 3 repeats forever, gallons per mile. So let's make these graphs simple. So again, when I say per gallon, gallon is going to be my x-axis here. I'm just going to go by ones to make it simple. And I'm going to go up to 10. And then on the other side is going to be miles. And it's 30 miles per gallon. I'm just going to go by 30s. So 30, 60, 90, 120, 150, 180, 210, 240, 270, 300. And so again, 1 gallon means 30 miles. 2 gallons then would be 60 miles. 3 gallons is 90 miles. 4 gallons is 120 miles. And this pattern should continue. So notice there are several characteristics that make this a proportional relationship. Can you remember what they are? It's a straight line. It has a constant rate of change. And it goes through the origin. So I know that this is a proportional relationship. What about our other graph here? So again, this number I know can seem a little bit intimidating. So it's about 3/100ths. So let's just kind of use 3/100ths. This is really similar to what we actually had the other day. So this is per mile, so I'm going to set up miles along the x-axis. And I'm just going to go by ones. Again, up to 10. And then the other side is going to be gallons. And I'm going to use this kind of factor to grow by. So again, let's say just for the sake of making it simpler, let's make it about 300ths. And so we'll have 300ths, 600ths, 900ths, 1200ths, 1500ths, 1800ths, 2100ths, 2400ths, 2700ths, and 3000ths, also known as 3/10. And so now I'm going to graph this. I'm going to go again. Every mile it's going to be 300ths. So 1 goes with 300ths, 2 goes with 600ths, 3 goes with 900ths, 4 goes with 1200ths. And again, I should see a straight line developing right here, because again, this is a proportional relationship, so all those pieces apply. It's a straight line with a constant rate, and it goes through the origin at 0, 0. Now let's write two equations that relate miles and gallons of gasoline. So one is going to start with M equals, the other is going to start with G equals. And so our two rates, we had 30 miles per gallon and 300ths of a gallon per mile. So per gallon, that's kind of my clue that I'm going to be multiplying by the number of gallons. So I'm going to think about this rate going right here. 30 times the gallons will give me the miles. That means that this guy here, per mile, 300ths is going to go right here. So 300ths times the number of miles will give me the number of gallons of gas that I need. So is this a proportional relationship? If so, how can you tell from the graph, table, and equation? So thinking about our table, we had gallons and miles, 1, 2, 3, 4, 30, 60, 90, 120. We also had our graph, and we had two graphs actually, but I'm just going to use this guy here, gallons and miles, kind of like this. And then we have an equation, and so I'm going to use this one here, miles equals 30G. So looking at this, how can I tell from the table that it's proportional? Because it is proportional. Well, what we're going to talk about here is that there's a constant rate of change. So as it goes up by 1 gallon, it goes up by 30 miles. 1 gallon, 30 miles. 1 gallon, 30 miles. So this is a constant rate of change. These are all equivalent ratios. So for example, 1 over 30 and 4 over 120, these form a proportion, right? So this is a proportional relationship. Looking at the graph, we've talked about how it's a straight line if it's proportional. It's straight because it has a constant rate of change. And it also goes through a really important point, which is 0, 0. We also call that the origin. Finally, the equation. So the equation has something really special, which we started talking about in class, called a constant of proportionality. And that is just a fancy word for the unit rate that makes this work. So again, this is a constant rate of change. And we call the specific value a constant of proportionality. So these two variables, we would say, have a proportional relationship. If the equation was m equals 30g plus 5, for example, that would not be a proportional relationship. There can't be anything else combined with that equation. It just needs to be the two variables and a constant multiplier involved. That's it for today. We will see you tomorrow to talk about more proportional relationships.